Hey guys, so today's lesson is actually going to split into two videos, trying to make them about 10 minutes each so that you can get the full coverage of what you need to know for your upcoming quiz and stuff like that. So at the end of this video, you'll see me again. I'll tell you guys, you can take a break or whatever if you need, and then make sure you go watch the second part of this video because you will be responsible for all the information that is in both parts. Alright, without further ado, let's go. So the next glacial landform that we have is what we call a hanging valley. A hanging valley is going to form because you get a uneven level of erosion between a main glacier and a tributary glacier. Alright, so the next type of landform that we're going to talk about is what we call a hanging valley. Now, hanging valleys form when you have differing levels of erosion between a main glacier and what we call a tributary glacier. They're smaller and they contribute to the main glacier. Now, when we talk about a hanging valley, what we're talking about is that there's going to be a different amount of erosion that happens between this guy and these smaller little tributary glaciers. The main glacier is going to erode. It's much bigger. It's got a lot more mass behind it, and so it's going to tend to erode a lot more material away than these guys are. Also, these glaciers are going to stop basically once they hit there, so they're not going to keep cutting through. And so what's going to end up happening is you're going to end up with what we call a hanging valley. So we saw this picture before. Here you have the main glacier eating away. Let's say the temperature goes up and the glacier melts away. You're going to end up with something like this. So here you have your glacial trough, which we saw in the last video. Okay, and this is where the main glacier was. Here was where you had your tributary glaciers. And so they eroded. They made their own glacial trough. You see the little U shape there. Okay, but what happened? They stopped. And so what happened is they create a valley that just kind of hangs over the bigger glacial valley. And so that's why we call it a hanging valley. And a lot of times you will tend to get like a little river here and you get a big waterfall like you see in this picture. Okay, you can see in this picture, you can see the U shape right here. This is where it was eroded away. So this space right here where my finger is was probably there where the main glacier was moving like this. And this space over here was probably where you had a tributary glacier working its way down. If you ever get to go out to Yosemite National Park out in California, you will see a whole bunch of these. The next glacial landform we're going to talk about are what we call Paternoster Lakes. Paternoster comes from the Latin meaning our father, and these guys are named because they literally look like the large beads on a rosary where you stop and say the Our Father. Now, where do they come from? Paternoster Lakes are formed by depressions in the ground created by quarrying and abrasion of a glacier. So a glacier is moving over the land, it quarries a large amount of material out of that, and it creates a depression. Later, when the glacier melts, it's going to fill in that depression. And so if we look at the picture in front of you right now, you can actually see here's the glacier, it's working down the valleys and things like that. Underneath it, it's quarrying, it's plucking, it's abrading. When the glacier melts, it's going to leave these depressions. As the glacier melts, it's water. The water is going to fill those depressions and create these various lakes that we call Paternoster Lakes. And you can see that there are a series of them connected in the picture on the right hand side. This is an actual photograph of a series of them. Now, you can tell that this is a glacial valley. Why? Look at the shape of the valley. It is U-shaped. So you can see that it's a U-shaped valley, and right directly in front of you, you can see the one Paternoster Lake. There might be a little stream or something that connects to the next one, which you can see a little bit in distance, and there's probably even a third or a fourth one as you work your way down through the rest of the landscape. Alright, so the next type of glacial landform is what we call a cirque. Now, cirques are prior zones of accumulation. What does that mean? That's the area where the glacier grew. We'll see that in the picture in a second. And a lot of times when you find these guys geologically, you find them with a small lake in the middle of them called a tarn. Now, none of those things mean anything until you see, once again, the picture we've been working with. So here you have your glacier, right? And cirques are going to typically form where you have your tributary glaciers. So see right here, this is where the glacier would have been growing from this area, or from this area, or from this area. Okay, so these would be the zones of accumulation. This is where the snow is falling and the glacier is growing. Okay, now eventually these glaciers are going to melt away and you're just going to be left with the landmass. And that landmass, that formed landmass, is what we call the cirque right here. Cirques are enclosed usually on three sides, and they have the opening that the glacier flowed out of on their one side. And so you can imagine the snow built up here and here and here and here. Okay, and eventually the glacier flowed out this way. Okay, and you can see the tarn in this cirque up here where the glacier would have flown out of. Now, this is an actual picture of one. So you can see you have your steep three sides here, and then you have your opening. So the glacier would have flowed down this way. Okay, now this one still has some snow and ice left in it, but eventually if all this snow and ice goes away, what you might end up with is a cirque that looks like this. So here's your cirque, 3 sides. Snow would have fallen, built up here, and eventually flowed out towards us in this general direction. Now, there might have been a depression, you might have had some quarrying, some plucking, or Lord knows what happened, and some of that melt water of the glacier as it melted collected into this small lake, which we call a tarn, and you can tell because it's surrounded by this 3-sided cirque. The next glacial landform is a weird sounding word. It's called a fjord. This is a Norwegian word. It might sound weird to you, although if you have been forced to watch Frozen or Frozen 2 4 million times like I have, you probably know the word. Okay, so how does this happen? Well, what basically happens is what you see in the picture in front of you. You had a river valley. Remember, we talked about how glaciers typically like to follow pre-existing river valleys and widen and deepen them. Well, that's exactly what's going to happen. In the picture before you, you see that green line, and that green line states that that's where the valley bottom, the river valley bottom, was before the glaciation. So that's the bottom of the river. Now, the glacier comes in. As the glacier comes in, it deepens that river valley. Obviously, it's going to be a U-shaped hole, very steep walls, okay? And it's going to deepen the river valley. And it's going to deepen it, You notice how there's a very deep portion, and then it rises up a little bit towards where the ocean is. Okay, now, if you look at the picture that you're looking at now, you can see that huge mass of ice is occupying the valley, and it's blocking off the sea. Okay, and you see how it's much, much deeper than actually the depth of the sea. And this is a characteristic of a fjord that we'll talk about in a second. Well, eventually what's going to happen? Eventually that glacier is going to melt. The ice age is going to end, and that glacier is going to melt. And what's going to happen is the ocean is going to flood that river valley. And that ocean water is going to flood that river valley. It's going to run up the river valley, and it's going to go very, very far inland. And so what you're going to end up with is this long, narrow, and very deep flooded river valley that we call the fjord. Okay, now that's one of the characteristics about fjords as well. They often tend to be deeper than the ocean that's right next to them. So where they hit the sea, they often tend to be much deeper in that area than the sea is right next to them. And so these are found all over the west coast of the United States. They're found all over Norway. They're one of the reasons why the Vikings and all those people were such good sailors, because there's so many of these that it makes the sea extend deep into the coastline, much further in than it should. And so you get these very beautiful, picturesque views like the picture that you're seeing right now. This is a fjord in Norway. Okay, they're absolutely beautiful. You can take riverboat cruises of them, up them, I should say, and they look absolutely beautiful. The next landform we're going to talk about is what we call a roche montagnée, a French word as described by French geologists for the first time. And these are primarily formed by very, very large masses of ice covering the continents, as you would find in a ice age. And they're important because they not only tell you that there was a glacier there when there's no glacier there today, but they actually give you indication as to the direction in which the glacier was moving. So if we look, here you have the bedrock. And one of the important things that you have to happen is it's not flat bedrock, but you're going to have rocks sticking out. Portions of the bedrock bulge out. So the whole area isn't flat. You got this portion that was sticking out. And so what happens is you have the glacier here, and imagine the glacier started on this side and moved this way. As the glacier starts to move this way, it starts to move uphill. When it starts to move uphill, you're going to have added pressure. The gravity is going to pull on the glacier extra hard. And what's going to start to happen is the very bottom part of the glacier is actually going to start to melt a little bit. As that glacier starts to melt a little bit, any particles that are in it are going to get rubbed up against this side, the uphill side of the little mound of rock here. Okay, and they're going to smooth it out, and they're going to abrade it, maybe create some scratch marks in it, but they're basically going to polish it or smooth it out a little bit, like we talked about with abrasion. And so on the uphill side, the part that the glacier first touched, you're going to get abrasion and scratch marks. So you see the glacier is moving this way. Now, what's going to happen is once it gets up here and starts to go down this side of the bedrock, what's going to happen is when it starts to go down, it no longer has that added pressure, and so the water that had melted no longer has that extra friction, that extra little bit of heat, and so it's going to freeze. And so any cracks that happen to exist in the rock that was here before, the water's going to sink into it, refreeze, because obviously it's got now surrounded by ice, and you're going to get frost wedging. And as the glacier keeps moving, that frost wedging is going to pluck this side of the hill away. And so what you're going to end up with is you're going to end up with a little hill attached to the ground. This isn't a pile of sediment. We're going to talk about something that's a pile of sediment that kind of looks like this in a little while, but this is a solid piece of the crust that one side has this gentle slope to it, and the other side has this like drop off. Now, it's still going to be relatively polished, but it's going to have one part where you had quarrying or plucking. And so what you actually get is something that looks like this. So if you look here, you can tell the glacier moved like this. And then it started to go down. And when it started to go down here, it plucked away the chunks of the rock on this side and polished and abraded the chunks of the rock on that side. Alright guys, so that does it for part 1 of today's video. If you need a break, like I said before, make sure you take it right now. Once you're done, come back and make sure you do part 2. You will be responsible for everything that I'm going to do in part 2, so make sure you're paying attention. Alright guys, see you in a couple minutes. Alright, bye.